Hey. So we're gonna start in 2 minutes, so everybody please take your seats. Thank you. Hello everybody and welcome to the first CocoaHeads Stockholm meetup of 2019. And I'm super excited to see all of you here tonight. We're gonna have an epic time. So for those of you who are new, CocoaHeads Stockholm is a monthly meetup, but it's also a great Slack community. So we have 350 plus chatting members on Slack. You can join the Slack group by going to our website, cocoaheadsstockholm.org. And you can also find us on all sorts of other social media channels. So for instance, we do live streams. So currently this talk right now is being live streamed on YouTube. Hello for all stream listeners. So you can check the stream out if you can't make it for a meetup. Also, we're recording all talks, so you can find them on YouTube afterwards. I also want to mention that for our stream, I think, Patrick, can you lower my voice a little bit? Patrick? Okay, thanks. Awesome. We're also sponsored by Epidemic Sound for the music we have on the stream and before the meetup. So they're super cool enough to give us a free subscription of their service for music. You can also find us on @CocoaHeads Stockholm. I suggest all of you to follow us because that's awesome, right? And we have our photographer here tonight, Kennett. So he's going to be snapping pictures of you. And I heard there's some glitches with the projector, so you might see that throughout the night, but it just comes and goes a little bit. It's all fine. Daniel is going to upload all the photos from the meetup later to Facebook and to meetup.com. All right, cool. So us who are organizing CocoaHeads are me and Edward, who sits here. We're also helped by by Patrick. And we have all great community photographers that I've already mentioned. We also have a code of conduct, so basically we don't tolerate any harassment of any form, or we tolerate all kinds of political views. So in case you notice anything that you're concerned about, please come talk to anybody of us, either in person or on Slack or on Twitter or email, or however you feel is appropriate. You can read the full code of conduct on our website. Speaking about diversity also, we always have guaranteed seats for women. And I got a question before this meetup, how to sign up for that. Basically, all you have to do is just join the waitlist, and we're gonna bump you up. Because usually we have last-minute cancellations, so that way you're just gonna get in front of the queue. All right, so please help us improve in any way. If you'd like to speak at a meetup, if you know any speaker, it could be an international speaker that you want us to fly over here to Stockholm, or if your company wants to host a meetup, please let us know, or if you have any ideas for future events or so. All right, and of course, take lots of photos, tweet, spread the word, use the Stockholm Tech hashtag if you're tweeting, and remember to mention us on @CocoaHeads Stockholm. So let's look at tonight's schedule. So tonight we're going to start off with a presentation from two developers, Truecaller, Guven and Claus, who are going to talk about a messaging platform that they have used Protobuf and some other interesting cool tech in. After that, we're going to have a presentation by Kennett, our photographer, about extensions in Swift and the possible overuse of extensions in Swift. I'm always really excited whenever Daniel talks because you always have some interesting backstory to everything. And then we're going to close off with a talk on snapshot testing by me. Just a quick intro to the new snapshot testing framework created by the Point 3 guys, and I'll show you how that works in detail. All right, cool. So tonight we're of course sponsored by Truecaller. So I'd like to invite them up on stage to have a little bit of a talk. So please give it up for Truecaller and Guven.
Yeah, I do. Hey, hey. Um, okay. Okay, I guess it's working. So, first of all, I would like to thank all of you for participating in this CocoaHeads meetup. This is Guven Iscan talking. I'm an iOS developer from Truecaller, and I've been here at the company for the last 2 years. So, in fact, it's like in my time, it's the second CocoaHeads meetup that we are hosting. But I'm really excited to see all of you here. And I would like to kick off with a bit of company introduction before we dive into technical stuff. So Truecaller is a global communication app which actually is released in Android and iOS regularly. And it's founded by two founders, Nami Zaringalam and Alan Mamedi in 2009. So at the moment, we are actually focusing on messaging, caller identification, and spam blocking. But on top of that, we have features like peer-to-peer payments, and also one other new feature, instant messaging, that we have just rolled out and that we are going to introduce to you today. So the company is headquartered in Sweden. This is the main office, but we got also offices in India and Kenya, Nairobi. And this is mainly because of the fact that we are really we have a strong market penetration in emerging markets. So this includes India, but also many like African countries. But like on top of that, we operate in like all the countries that actually like that actually have App Store or Play Store. So we can say app is a multinational cross-platform one. So we actually strive to provide you a better communication experience in Truecaller. So you can see screenshots from our Android app and iOS app. So in the Android app, there is one after call screen where we have successfully identified a caller, which was unknown before the call. And we are trying to replicate the same functionality on iOS using CallKit extension. And on the last rightmost screenshot, you can see the like instant messaging that solution that we have implemented on iOS. So this is a graph of user growth in Truecaller. So the graph is actually running from 2010 to 2017. So you can see the rapid growth. It's for the number of downloads that we have, which is over 300 million at the moment. But on top of that, we got also 130 million daily active users and like 4.5 billion like numbers that we can identify that resides in our database. So we approximately like identify 1 billion spam calls every month. So like in Truecaller, it's like it's a period where we are actually scaling up. We are transitioning from being a startup to a scale-up, and we are recruiting heavily, and this includes iOS developers as well. So, like junior and senior engineers, they are both welcome to apply, and you can spread the word to your friends as well. Yeah, and so this is mostly it for the company introduction. I hope like it was fun. So we are going to talk about the instant messaging solution that we have, as I mentioned, and I'm going to like co-present it with my colleague, Claus. So we have recently rolled out instant messaging in both Android and the iOS app. It happened in the last couple of months. And we have used GRPC and Protobuf extensively in both of the like platforms. So if you look at the overview of the presentation, I'll just go over briefly the the product features and how we like the basics of GRPC and Protobuf. We will talk a bit on code generation and how you can integrate it. And also, like, we will be finishing off with, how you can actually, like, accommodate versioning changes in the, like, networking definitions and how you have the interface. So Truecaller IM is quite similar to other, like, instant messaging solutions that you can find in the market. We provide it in Android and iOS. So it supports the like basic media types like video, message, location, and contact sharing. At the moment, it's only available as a one-to-one communication platform, but like soon we are planning to actually expand it to support like group messaging. And one nice feature which actually applies to the Android app is that it brings functionality which is really close to iMessage that we had in iOS for years. So you will be able to actually switch between SMS and instant message. And the color scheme is also quite similar with green and blue. One other feature that we have like over the like other instant messaging like solutions is to be able to do spam link detection. So as I said, we have like a strong like user audience, huge growth in the emerging markets, and they sometimes have the problem with fake news. So this is a crowdsourced solution to be able to like identify URLs that we have like while we are chatting, so that users can know if it's spam URL or not before they actually click on a link. And yeah, and that's mostly it for the IAM part. And soon, I think Claus will talk more on the future work that we are planning to do. So I would like to dive into a bit of the technical stack. So we used Protobuf and GRPC, as I mentioned. And both of them were actually technologies that we were using previously for other services, like heavy load services that we had. So this is basically a significant change from the regular HTTP connections that you have in your mobile apps. So instead of using Alamo Fire or AF networking or similar solutions, this one uses HTTP2, which I will come in shortly. But I would like to start with Protobuf, the model definition language that the GRPC is using. So it's basically a interface definition language. So what you have is actually a tool developed by Google starting from 2001, and then it has become public in 2008. So it's basically a data format and interface definition language, which you can compile into many different languages. So assume I'm defining two objects, like a joke and a comedian. You would have the field types and the field names, along with the order of the fields, which helps with serializing and deserializing. And then you would be able to actually convert these objects into the language that you want. So for example, you would be able to convert them into Objective-C, Java, JavaScript, Python, and C++. But there are many other languages that you can use. And you would be able to, instead of doing all the JSON serialization, you would be able to, serialize them into binary format, which would give you some, advantage, in terms of overheads that you have, and also, it will cut on resources. So at the moment, the project is still, maintained by Google, but all are open source. And the Swift support is actually maintained by Apple. So I shared the link down here, and you can go and take a look. Objective-C support is actually maintained by Google at the moment, but both are actually fine to use. So when we started doing IAM, actually, the Swift support was in beta. So we didn't want to actually use it. So we went with Objective-C. But you can safely use the Swift language generation as well. So gRPC is the way to communicate if we are to say protobuf objects are the model objects that you are going to actually transmit. gRPC is the networking layer where you define the methods on the endpoint or the backend side, where you can actually call you are calling a local resource, like something in your local runtime. So it will give you both synchronous and asynchronous communication means. And you would be able to look at all the source code that you have. So the official repository is in GitHub. You can take a look there. And you would be able to actually find other languages which are supported by gRPC. So Protobuf and gRPC, they're supported by multiple languages, and you can use it to define both your client and server architecture in the language that you want. So we use the Proto language to define the service, the methods that we have. And assume we have an endpoint like Comedy Central, where we actually fetch our jokes. So you can define it like a remote procedure call, where you have a get joke method, which returns a joke. So it can be called, as I said, synchronous or asynchronous. But the point is to actually be able to share this, single definition over multiple languages and platforms. So gRPC uses HTTP2 for data transport, which means that it's like much more optimized compared to HTTP. And you will be doing your definitions in Protobuf. And the supported languages, which are quite extensive, contains Objective-C and Swift as well. So you can define your client architecture, your client implementation in these two languages, and the backend can support maybe like Node.js or C# or Java. And so HTTP2 is the underlying communication way in gRPC. You can send there are multiple actually enhancements over HTTP, which comes with HTTP2. So with this one, you are able to actually do multiple requests over a single communication channel, which means that you don't have to exchange the headers all the time. You don't have to define which HTTP method that you want to use. And also it supports header compression, which means that if you're not going to change the header in a request, you are able to send it in a much more compressed way. And these are actually all residing on a binary protocol versus compared to the textual HTTP, where you can see this is a get method, it returned 200 or some other error code, and you're able to see all the JSON content. And it actually this has been started as in under another project name named Speedy, and has been also developed by Google, and they're claiming it's providing up to 60% better performance over the regular HTTP. Lastly, I would like to talk about streams, which we didn't have in HTTP. So this basically means that you can keep a channel open to between your backend and your client. So this channel can be unidirectional. It can be bidirectional, meaning that you can send a series of events or you can receive a series of events. I mean, of course, the regular request and response method, it still applies and you can still use it. But this is much more efficient if you want to transmit chunks of data, like images or a series of events like we did in instant messaging, where we receive a series of messages or reports. So what we do basically is to, once we receive an event, we immediately send back an acknowledgement, setting up a ping-pong type of communication. This acknowledgement means that the client was successful to receive the event and lets the backend know that it can send other events. And this way you can actually ensure the ordering of all the messages, all the data packs. They're fine and you can trust on the ordering. So I'm going to now hand over to my colleague, Claus, who is going to run over some example code, and we'll tell you more about how you can integrate gRPC and Protobuf. So thank you for listening to me.
Is this on? Yeah, it's good. All right, yeah. So what I would like to walk you through is a bit about how we managed to set up using gRPC and Protobuf, in our case with CocoaPods, and how we have. It's very easy to generate a sample implementation. So just going to switch out of the presentation here for a sec. We can figure out how to do that. Sorry. There. Cool. New keyboard. Cool. Yes. So this should be readable. Good. Yeah. So here's a more extensive example of a Protobuf sample. What we typically do is we have the Protobuf file shared in a submodule with our server teams, because they use the exact same definitions to generate the server side. And here's an example service sort of messaging. It's a simplified version of what we do at Truecaller. We have a standard register call where you register your user. You can like think of it as sign in, and there's sample send message method, and then just a few more like example inputs like user. The more interesting one is the message content, so in our case we have text, we got image, we got video. And actually in the real Truecaller app we have contact cards and location sharing as well. But this is like a simplified version. So setting this up in a pod spec is using the Proto compiler plugin, also provided by Google. It's one of the easiest way of integrating it into your project. This runs run the standard Protoc tool, which you can also download separately, including you can download the Protoc Swift one from the link Guven showed you earlier, generates the output files. So what this will generate is a bunch of rather verbose, hard to read code that you don't necessarily have to care too much about, but the usage of it is very simple. So for example, for a simple register call, the method here, all I do set up is set up a register request. I call the RPC register, and it will like call the register, and then we get a response back. The only thing we have to do is to set up like authentication headers as appropriate if we need those, and start the request. And similar for messaging, what we set up is in this case we set up the recipient, so like the person you want to talk to, and then in the message request we say who do you want to talk to, what's the message content, in our case just text, but this could be an image, and the image content, like in my Protobuf, I set it up with just the URI, but you could have it as binary blob, you could have thumbnail properties, width, height, the whole 9 yards as you please. And again, very simple. You just start the request, fire it off. You don't have to do any of the networking part. That's all done for you by the GRPC library. So all retry, all serialization, all of it is done for you. This is very convenient. And again, so this is a cross-platform solution we use with the iOS and Android, and one of the main highlights of this is that rather than dealing with slightly different model objects, like maybe iOS would serialize, like expect yes, no, instead of true, false for deserializing a Boolean. In this case, we don't have to deal with that. It's done for us by library, so you guarantee that you'll have the same module on the server, on the Android client, on the iOS client. So it gives a huge boost to productivity for the teams. Also, when we use APNS for standard push notifications, instead of sending the content there, we send a base64 encoded version of the GRPC blob, which is a binary, and then we simply just ask the GRPC library, make me an object of the data you just sent me. So once again, we don't have to do any manual deserialization. It's all done for us by the library, which is hugely convenient. And then one of the other really nice features is versioning. So essentially we can support different type of messages. Once we have a new version of the Proto spec, let's say we have just have video and audio, but then we want to add like voice messages, or we want to add location sharing, we just simply go and add that. And if it's not supported, the version library can allow us to either downgrade, fall back to just the text version only, or we can have like a full version fallback where we decide to say the messaging version you have right now, we had a breaking change, you have to upgrade, otherwise you can't use it. But it's not like we're going to have like an immediate crash because suddenly we deserializing a JSON field to the wrong type. That's not happening because we got versioning, which is somewhat hard to build with regular JSON. But as with most things, GRPC has some, and Protobuf has some good and some nice things, and some bad things. So again, the goods, it's lightweight, binary encoded, uses very few resources, both client and server, shared network platform layer. I believe they all built in all C++, so interface description providers between endpoints, you don't have to like set up your own like routes as you may do in Alarmify today. No manual serialization, as mentioned a few times now, so a lot less code to write, which is always nice. And again, strongly guarantee the same object model between iOS and client. And I should have added server here as well, because that is a huge benefit. You're not going to have the case where the server team comes and tells you, oh, by the way, we updated the JSON model. Now it's totally different and breaks your app, because that sucks. The bad stuff is that the generate Objective-C code it's not pretty. It's not really pretty when you're into that advanced stuff. Even worse is the lack of proper error handling, which is quite complicated. We get a standard NS error on iOS, which we then have to take the localized description of in order to get a string constant that may or may not mean something. So that's definitely an error we hope they can improve in. And it's incredibly hard to unit test. So with AF networking and Alamofire, etc., you can use like HTTP stubbing. That doesn't really work that well when it's a binary content you're trying to stub out. Now, we did manage to find some evil ways of abusing extensions, among other things, to mock out the types, but I'm not really sure we would recommend that too much to do, but it was a fun exercise. Future work for us is to add group support, which hopefully won't be too difficult. And then we're also looking to use this to add end-to-end encryption. And at least the nice part about this is if we do this through the framework, then once we just do updated versioning, we don't have to have Android and iOS doesn't have to go and implement separate encryption support. It should all just work through the framework. And that this is what have been enable us to build an IM client in, well, coming from, I previously worked at Skype, so this was very fast. We built it in like, what, 6 months or less? And that's, I've never seen it done that fast before. So that was very impressive. So yeah, I think that's it. We have time for a few questions if anyone asks anything.
So maybe we should do like this. If you raise your hand and ask the question, if you can repeat it to our streamers since we're only having one hand mic.
Absolutely. Okay, so the question was if we would recommend using Protobuf to define like a unified object model and constants. And I think that would be very nice. I'm not 100% sure if it supports it out of the box. And we use Firebase to have configurable variables for most of these things today. So essentially a different endpoint, so we can configure them at runtime. But I think it's if it's possible, then I would probably recommend it, yes.
So you can find support for things like enums, like nested structures, static variables. You can find stuff like protection level identifiers, like internal, public, protected, those kind of things. But there is also a bit of overhead because you are not like in Proto2, you can find like optional and required like identifiers. But since everything has to be shared between all the platforms that are supporting it, I would say that there is going to be a minimal, overhead compared to doing everything like manually. But still, I would use it to make sure that the object graph is the same and you're able to actually serialize and deserialize it into binary data.
And actually, just to add a bit to that, I think once we build group support to add on top of this, that'll be like the ultimate challenge in either proving or disproving that the framework can support building the same feature across 2 platforms at the same time and extending on it at the same time. All right. Thank you.
All right, so now it's time for Daniel Kennett. Please give it up. What is he doing?
I'm a photographer, but I'm giving a talk. It's difficult.
Okay, now give it up for Daniel Kennett.
Thank you. Hello, everybody. My name's Daniel. You may have seen me before. So, a couple of weeks ago, on the Slack, somebody said, we're short for speakers this month. Does anybody have something they can talk about? And I jokingly said, well, there's this thing I'm annoyed about right now. I could give a talk about that. And they were like, yeah, all right. So I'm like, So this is a talk about Swift extensions. And you should listen to me because I've been developing apps on Apple platforms since Xcode was called Project Builder, and it looked like this. You should not listen to me because this is very much an opinion piece. My opinions are quite stupid quite often. They are also wrong fairly often, and more often they're both. So, just a disclaimer. So, extensions are a very nice feature in Swift that are very powerful. And with powerful language features, often comes the problem of it gives you enough rope to hang yourself with problem. This is very common in C++ with templating, if you're aware with that. So I consider extensions enough rope to hang yourself with feature. So, for example, other ones in Swift are like, you can use emoji as symbols. That's super great until you see code like this. And it's like, you can have custom operators and operator overloading. That's super great until you see code like this. And this is great, and you'll write something like this, and you'll feel very clever with yourself. And then a new person will come to the code base, and they'll just... No, was this? Oh, no, sorry. I think I meant to start with the company down the street. I'm sorry. So to just give a little step back, a Swift extension is a way of adding some set of things to a class that has already been declared elsewhere, whether it's in your own code base or in another code base. Swift extensions are... Class extensions are also present in Objective-C. In Objective-C, they're called categories, and they've been around since forever. Protocol extensions are newer. So a protocol extension is a way of attaching code to a protocol. Now, a protocol without extensions is basically a list of methods with no implementation. So being able to attach implementation to a thing that is a thing with no implementation gives a lot of power and is open to quite a lot of abuse. Because protocols in Objective-C are more or less metadata only, the protocol extensions are not a part of Objective-C. So what happened a few years ago is WWDC came around in 2016, I believe, and this talk came out. And then the Swift community saw it, and their minds were just blown. And what happened was protocol-oriented programming. And protocol-oriented programming is the idea that you put protocols first. So the default way of programming is using protocols. Now, this is a valid way of programming, of course, but with all new things, people just took it and ran. So what happened was we had some code like this. We have two very separate objects that have names. And they're like, well, we should do this as a protocol. Fine so far. But because we can attach code to the protocol, we don't have to have code in the class anymore. So then this happened. So now, because we don't have to have code in the class, we just have this instead. which is super great, because we did have this. And like, dry means don't repeat yourself. And we are very clearly repeating ourselves here. But here, we're not repeating ourselves. I mean, there's 4 times as much code, but we're not, if you ignore the fact that we are repeating ourselves, we're not repeating ourselves anymore. And then what happened is we started to take this, where we'd have a class, a view controller, that conformed to some protocols, and we'd have them in here. And then this happened. And you're probably thinking, what's wrong with this? And on the surface, there's nothing wrong with this. But let's look at what extension actually means. So this is a house. This thing here is an extension. It was added to the house after the house was built. These things here are not extensions. They are windows, which is an unfortunate thing, but because they're on Apple platforms. These were not added after the house was built. They are part of the core house. You wouldn't put a toilet in a house and going, yeah, I'm extending this house. To flip it around and put it back to code, if you think about the word extension and what it means and how they tend to be used, if you remove all of the extensions from a class, its base functionality should still be consistent and operational. So if you have a view controller that has a table view in it, and you took away the thing that implements the table views, this is no longer a table view controller. This is just a view controller that somebody else added table view functionality to. But Daniel, I hear you cry. Table views are a really nice way to organize my code. Look, if you've got a huge view controller, this diff isn't helping. Especially because from here down, you don't have stored properties anymore. You have to, you know, if you have a little function down here and you want to just have a little property that stores some state, nope, that can't be in there anymore. So you need to like add a property up here, even though it's miles away from the code that uses it. You know, not very nice. But Daniel, I disagree. So mark comments are about as much use in code organization as extensions, because extensions aren't really picked up by the open quickly thingamy. And if you have a class that's large enough where just adding these little categories, this is the jump menu. So if you click to this menu to the right of your file name in Xcode, you get a list of all the symbols in the file. And these mark comments appear. So the hyphen makes a divider line and the text makes an entry in the menu. If adding these mark comments isn't enough, it's probably the symptom of a larger problem. So if you've got a class that's so huge that you have to split it up into extensions, you might want to consider having sub-objects for the functionality, splitting it up into sub-view controllers entirely, and so on. And I've often seen the thing that, but like, you know, small code blocks is easy to understand. But the problem is if you start splitting your code up into small code blocks, when you're adding more code, you'll add more code blocks. And you'll be in a file, and you're like, oh, this other class over here needs more functionality. Well, I'm in this file now, so I'll just add an extension to the top of my file for the other class to add the functionality. And you end up with a class that's implemented like over, what, 10 files? And then if you come into it from somewhere else, it's a huge pain to find out where everything is. So having like one block with all of the class, all of the code for a class in it, is not bad. It's very, very, very useful as a new coder, yourself coming back a month later, to be able to open a file, see that, and know, okay, everything I need to know about how this class works and its core functionality is here. I don't need to like command click all symbols and you know, trying to figure out where everything is. And I've seen code like this. Like, This is a list of numbers. It doesn't need two completely separate compilable things. Like you just like there's no point. Like, you know, don't make John Travolta sad. Right? Just it's fine. This is fine. There's no problem. Another thing that I didn't make a slide of is that a Swift currently doesn't like you having optional methods in protocols. It's an Objective-C feature that does work in Swift, but Swift doesn't like you doing it. Like, it works perfectly fine. You can have optional function pointers in Swift any way you like, but in protocols it doesn't like you doing it unless you declare the protocol Objective-C available, and then you can just fine. And the common answer to that is, well, if we have a default implementation that's empty with Swift protocol extensions, they're effectively optional. The problem with this from the other side of this equation as the client of that protocol is you have a list of methods that you have to implement, except some of them have default implementations, so you don't have to implement them. But the code doesn't actually tell you that because there's no metadata to tell you. So basically, you don't implement any, and then you just push the button in Xcode until it stops complaining. And then the ones that aren't there, you can then optionally implement. So that's horrible. So other than me just complaining and like not liking to open 20 files to figure out how a class works, there is actually a compile time cost to extensions. So I made a script that generates 10,000 files. No, 1,000 files, 10,000 made my computer go weird, that implements these protocols. So very, very simple protocols. Protocol A, function A, protocol B, function B. Protocol C, which is A and B, which has that. No default implementations, nothing. So 10,000 classes that are this, but with a different number up here. Took about 12.5 seconds to compile on my computer. Splitting them out into extensions like this, like a very simple way of doing extensions, like averaged it up like 2%. Like, it's basically insignificant. However, doing it via I forget the name of how this kind of extension by protocol extensions actually increased the compile time by 28%, which is not insignificant. Right? If you have a ton of code like this, we have really strict, things here. Sorry? Constraints, thank you very much. Very strict constraints here. You can really ramp up your compile time. And of course, 1,000 files like this is not common, but it's a 30% increase for the simplest case I could come up with. The Swift language is Swift, but the compiler is not. So you're like, well, this guy must hate extensions, damn. But no, extensions actually are really good. So there are lots and lots of really wonderful ways to use extensions, and they are a really great addition to the language. So I like to use it for bridging internal and public types. So if you have a type somewhere in your code base that you don't want to leak out to your client, so if you're using some framework in your code that does network requests or whatever, and you want to sort of extend some state out, but you don't want to have your network libraries, implementation details leaked to your app, you can just add extensions to the internal types that convert them. Again, with different unit conversions as well. Like if you have a coordinate, you can just extend the call location coordinate to support the SWIREF system very simply. It's very nice for little things like that. I also like it because you can add stored properties via an extension if you have any object that is in the Objective-C runtime, which is everything Apple gives you. So any UI kit class, any foundation class, you can use a feature called associated objects to attach properties to an object arbitrarily. So like this, you can make a stored property, and you can make this not any. And that's super nice as well. There's a ton of examples. I'm not, it is a nice feature. Yeah, so that's me just ranting about extensions and stuff. hope you enjoyed it. Hope you're not too angry. Any questions? Yes. You didn't tell me a story. All right, so I was in a code base, and there was a method, and I was like, okay, this isn't in the class. I just refactored the class, and I haven't seen this at all. And I command-clicked it, and I got to a protocol. And I command-clicked that, and I got to a sub-protocol or something. And it took me 20 minutes to find the implementation of this method. That's basically the story of why I was angry. And I mean, I am guilty of quite a lot of the stuff in here. I have an API that is way too big. It has a protocol, and it's huge. It's too big. And I've split it up into sub-protocols. So the camera protocol is camera live view, camera properties, camera connection. And I've implemented one of the cameras in separate files, one for each sub-protocol, just as an extension, as an extension, as an extension. So all of my stored properties are in the core class as internal, because they can't be private anymore, between files, and then just with underscores, and then that's it's hard. Don't do it. I hate myself more than anybody else, really.
No more questions for Daniel?
Cool.
Well, thank you very much.
Thank you for listening.
All right. Whoa, whoa. Okay, something like this. Is this a good level? Okay, great. So, hi. So, as you might know, I'm Alek. Let me get my presenter notes there. So you can find me at Mr. Alek on Twitter. I have also a very outdated blog on iosnomad.com. I've been doing iOS since iOS 4. And actually, I just noticed like a few weeks ago when I was updating my app that my first app, Min Firma, has been out in the App Store as a paid app for 8 years now, and people are still buying it. It's incredible. So I used to work for a startup called Doer. I have some of my fine former colleagues here tonight. But recently, 2 weeks ago, I joined probably the craziest thing I've done in my life, which is a startup generator/incubator program called Antler. So basically, we're 67 people with all various different backgrounds who are supposed to all start a new company in 2 months, and then build that company for 3 months, and then have like a huge demo day with like tons of investors. So I've been really stressed out about this, and it's been really great to like kind of come back to the good old CocoaHeads community that I feel much more comfortable with. All right, so today I'm going to talk about this new testing framework called snapshot testing. So first, a raise of hands. Who has worked with any kind of snapshot testing framework before? Oh, quite many. That's fun. If you keep raising your hands. So now, keep raising your hands if you've used this thing. Oh, a few people, but okay. So some people lowered their hands, which is good. That means that probably you've tried out FB snapshot test case before, or after Uber took it over and made the iOS snapshot test case, and you want to learn more about this new hot thing, which is great because I love it. So the new snapshot testing framework is created by the guys behind Point Free, which is like this Swift video series, kind of like what Chris Sidoff and the Objective-C.io guys did with their video series. And it's all done in Swift, as compared to the old FB snapshot test case library, which was done in Objective-C. So, okay, snapshot testing, the basics. So snapshot tests, they run as unit tests. You don't have to run them as UI tests, which is great because unit tests are much easier to run and they go much faster, right? And you're in much more control over the code. So it works like this. First run, it captures a snapshot. A snapshot can be anything, and I'm going to get to that in just a second. But it then saves that snapshot. You commit those snapshots of your test to your repository together with the code. Those become your fixtures for the tests. And on later runs, it just captures a new snapshot and compares that to the old one that you have saved. So it's a really easy concept, right? So what can you snapshot? Well, the most obvious thing is views and view controllers, right? So this is the syntax. You just import snapshot testing, and then you can, in your unit tests, do a search snapshot matching a reference to a view or a view controller. And then what's interesting is that for each thing that you can snapshot, you can use different what's called snapshot strategies. So for instance, for a view controller, you can take a snapshot of an image. So it's going to render it in a UI kit and take an image of that. Or you can also snapshot the recursive description of the view controller. So that way, you're going to get back the view hierarchy and all the properties on different views. So I'm going to show all of this in a demo later. One thing to note here is that you can simulate specific devices with this snapshotting for view controllers, but it can be really tricky. There are caveats to it. So if you currently, there's one limitation where basically all your machines that run these snapshot tests have to be set up to use the same kind of simulator, because else, if they have like different scaling, if you have an iPhone X and an iPhone 5, and you have like one 2x device and a 3x device, the screenshots gonna come out different. So even though you can like technically simulate this using, so what's done under hood is that it used trait collections and it just use different frames for different devices you want to simulate. It doesn't really work that well in practice currently. Another thing you can do is also to use a parameter for lowering the precision. So imagine that you have a case where you don't always get pixel perfect results back, but it's maybe 95% perfect and just fluctuates those last pixels over time. What you can do then is just attach another parameter to these functions. Okay. So more things you can snapshot. You can actually snapshot anything. You can snapshot encodables and take snapshots of them as JSON or asplists. Super simple, right? You just take any objects, implement the encodable protocol. But it doesn't end there. You can actually dump whatever memory. So you can take a struct and you can assert a snapshot with the dump strategy. And what's going to do is it's going to use the Swift reflection API to get all the properties out and print out all the values, and you're going to see them in a text file later. Okay, so I'm going to show you all of this in a demo. So and also, first of all, huge thanks to first Patrick, who's providing the laptop for me since my laptop is running the streaming, and Frederick and Robin in the back, who kind of panically set up a workaround for me in a pod file, which just blew everything up. So I'm going to switch to mirroring so you can see what's going on. So basically, if you would at any point have any troubles setting this up on your computer using CocoaPods, this is a great workaround for a problem that might show up. Okay, so we're not gonna talk about that that much more. Okay, so I have a really simple demo set up here. I'm gonna run the app, and you're gonna see it's not even an app, right? It's the simplest thing you've ever seen. It's just a view controller. Hello, snapshot testing. It has some kind of view which says boo for some reason. Okay, so let's see how we can snapshot test this. So here we have our unit tests. Let's first start out to look at the view controller. So what I'm doing is just importing the snapshot testing framework. We can ignore this for later. And then with my view controller, it sits in a storyboard. So let's look at that storyboard. So it's really simple, right? It has this view controller, it has a custom view. It's actually IB designable, but it seems like it's taking a while for that to render. So the only thing you do here is get an instance of the view controller, and then you can just start asserting the snapshot. So now let me see here. I run this test and let's see what happens. Okay, so since this is the first time I ran these tests, it says failed, no reference was found on disk, and then it says automatically record a snapshot. And you can see down here in the console where it saved the snapshot. And it actually saves it in the same folder as your test in a subfolder called snapshots. So let's look at that. So here we have the project, and inside the test folder, there's a snapshots folder. I don't know if you can see, but in there's a folder called Snapshot Test Demo Tests, which is the name of this test class. So we got the rendered image here. Perfect, right? And since we also did this recursive description snapshot, we get that as well. And you cannot see that very well. Let me see if I can actually turn on the accessibility zoom things. I'm not using my own laptop, so okay, great. So, as you can see, it's printed out the view hierarchy. You see the frame of this view controller's view. You see what subviews it has. It has this custom rounded view, which in turn contains a label. It has another label. So this is another way of doing the snapshot. So you can use both strategies or the one or other, depending on what you prefer. So if I run this test again, now that we have these recorded snapshots in place, then it should go green. Perfect, right? And if we change something, come on, interface builder. So we can just change text here in the label to just say hello. Run the test again. And it would fail, right? Expected snapshot to match reference. It didn't. And what's interesting is that you can have a look here in Xcode in this furthermost right tab. You can look at the test, and inside it actually gives you the diff. So I can now look at the reference. I can look at the failure, and I can look at the difference. So here I see where things went wrong. This is pretty nice, right? And of course, if you're doing this on your CI, then you can start automating stuff, so maybe even post. We never went that far with the demo I was involved in at Doer, but you could, in theory, take these diffs and maybe post them as a comment in your GitHub pull request whenever there's a failure. Okay, so let's ignore this for later. Now, next thing you can test is a view, right? So we have this this custom view. It's called rounded view. You saw it earlier in the simulator. It's basically just a view with rounded corners with a text label inside. You can see the code for it here. It has a backing layer which just sets the corner radius every time you change the bounds. And you can set a text. And let's ignore the style for now. So it has a style with some background colors, but basically this is just any other custom view which is IB designable. It doesn't have to be IB designable, but it works with that as well. So we can run a snapshot test here too. One thing to note here. So first of all, we create the view, we set the properties, and we assert the snapshot. Just as last time, first time it runs, it creates the first initial snapshot for us. We got it right here. And subsequent times, it's going to go green. One thing to note is that you need to set the frame of the view in some kind of way, because if you try to render this with a 0 frame, it's not going to work. And if you're using auto layout, the best way of doing this is to just set the frame with the size of what auto layout thinks is the proper size for this view, how it would lay it out if you would actually add it as a subview to the view hierarchy. So you can use that with this really quick extension, just setting the frame to system layout size fitting, and you can either use expanded size or compressed size here. Doesn't have any big difference. Okay, so cool. We can test view controllers and we can test views. Nothing really spectacular yet. Now, let's say that you would like to test all these different styles. So we have an enum here. So this view can be normal or warning or error in its style. So one fun little hack that I discovered, which really improved my working flow with snapshot testing, was that you can actually iterate and do this in a loop. So here we have a test. Just as before, it sets up this view, it says the text, it says its sizes. But then, since I made this style property case iterable, that means that it's going to get this all cases property, which consists of the normal, warning, and error. What I can do is create a for loop. I go through all the styles, and in the loop, I set the style on the view, take a snapshot, then next turn in the loop, set the new style, take a snapshot, and this becomes really interesting. So we're going to run that and see what happens. Just as before, it's going to say it's created references. So now, let's look at what actually happened. So we got this test function called test rounded view styles. And what snapshot testing did was to create 3 screenshots. So let's, So we have test rounded view styles 1, .1, .2, .3. And now, suddenly, we have snapshots for all our different styles. And now you can only imagine and extrapolate how powerful this can be when you're building new custom views, because it makes it really, really simple to iterate through and test all your cases. And especially if you're doing any kind of refactoring, you can iterate through all the different cases. You do the refactoring, and if you screw anything up on one specific case, it's going to tell you exactly what case screwed up, and you're going to see how. So this really enables you to get a kind of a TDD style of programming for views, which really was mind-blowing for me. And it works really well when you're creating new views as well. You can set all these snapshots up, and I usually have the workflow where I have the code and I have a window with the snapshots here, and I do some changes to the code, run the unit test, look at the snapshots, and look at them and see, is this what I want the view to look like? If yes, okay, keep going on adding the next thing. Otherwise, I just delete them, do some more tweaks, run again, and see what the snapshots do this time. I think it enables a really powerful workflow. Okay, so the last thing you can do, which I want to show, is how you can use this to test other things than views. So in this case, this might be a contrived example, but I have this user model. It has a username, which is a string, and an email address as a string. So this could be whatever properties, right? And this user model also implements the codable protocol. So what I can do then, by making it encodable, I can take a snapshot as JSON. And actually, without encodable, so let's try that out first, I can just dump it. So what it's going to do, it's going to use the Swift Mirror API to look through all the different variables in the struct. And it's going to show us to us. Yeah, here we go. So this is what it outputs. And this is with 0 code, right? I just said, take a snapshot of this whatever thing. You have no idea how it looks like. Just dump the memory. And immediately you can see how it's really surprising how readable it still gets, right? And if you just make this encodable, then you can start taking snapshots as JSONs orplists or whatever you like. So this enables you to, instead of so maybe you're testing things today where, okay, let's see. Yeah, so this is the JSON. Super simple. So maybe today you're testing some things with unit tests where you have JSON output, and you have to include that JSON output to your test bundle, and you have your fixtures.json files somewhere that you test against, and you have to update them manually whenever something changes. Maybe you have like some API service, you want to change that, and you want to assert that it outputs what you expect, right? By using snapshot testing, you don't have to do these fixtures beforehand. You can just take a snapshot, look at the snapshot, and check, was this what I expected? Is this how it's supposed to be? Okay, great. Then leave it be. Otherwise, you just delete it, make changes to your code, look at the snapshot again. Really powerful. Okay. So, some learnings from this. It's really, really, really simple to get started with. Like literally, I think if you haven't tried it yet, just do it when you have a spare half an hour. You don't need more time than that. You're going to see immediate benefits. It's really extensible. So these different snapshot strategies, there's a blog post out on point 3 where they make an extension for attributed strings. So basically they create a new snapshot strategy where you can type assert matching this attributed string as image. And then they've implemented the image strategy for the attributed string by just rendering it in a label. So you can do lots of powerful stuff with this. And as mentioned, it enables TDD for views, which is, for me, mind-blowing. Enables the needs for fixtures. Yeah, I mentioned this before. You need to use the same simulator when generating the images as you're going to run on your CI. So make sure to either look up what simulator your CI is using or have that in a config. Just make sure it happens, because otherwise you're going to scratch your head and wonder, why is this not matching? And possibly, if you're doing this on a large project, which you already have, you might get some initial false positives from various things, depending on your CI pipeline. But it shouldn't be too tricky. Okay, so the verdict, I think this is absolutely incredible, and I really think all you should try it out. And yeah, that's kind of it for me. Thanks. So, any questions? Martin.
Thanks for the great presentation. This is definitely a good tool and good spell. So, I've noticed that the Facebook's now, Uber's snapshot testing has only image comparison. There's an issue where between iOS 10 and further, there's a small change in how the system represents fonts, and you get a lot of false negatives. Quite often it's solved by ignoring percentage-wise what you try to do. Does the same issue persist here? I haven't tried it yet with different operating systems. I only tried it with
So I'm going to repeat the question. So the question was that for these other libraries, FB Snapshot Test Case and iOS Snapshot Test Case, they had some problem with certain iOS versions rendering fonts differently, and that gave a lot of false positives. And thus, snapshot testing from point 3 have that same problem. I believe they do. So yeah, either it depends on if you can live with only doing snapshots on iOS 11 and upwards. Yeah, that's one fix. Other than that, I guess you have to do the percentage granularity to not get false positives. So I don't know more than that actually.
What's your strategy for keeping the images? Do you keep them on the servers, and how do you check them in to get more?
So the question was, how do you deal with the images? Where do you store them? What we've been doing before a doer is to just check them into the repository. That has been the easiest way, and by default, the framework adds the snapshot files right to the same folder where your tests are. So that has been also that's really interesting because if you create a new view and you use the snapshot tests and you create a PR for your team to look at, that really aids all your team members reviewing that PR as well to have those snapshots, because then they can see here's the code and here are all the snapshots for all the different cases, instead of having to, either you would typically like maybe include a GIF or you'd have to check out the code, and most usually developers are lazy, right? We don't take the time to actually check out the code and look at everything, but these snapshot tests really help the reviewing process, because if you've done your snapshots, they're all there and you can see all the cases, and then you can comment on them and see, hey, wait a minute, in this case this doesn't look very pretty. Daniel was before you.
So in the modern iOS world, we're moving to a more and more fluid UI. So like on iPad we have split screen. On all OSs we have dynamic type. We have accessibility features to involve text and outlines and whatnot. Would you consider that a snapshot testing system optimizes us to concentrate on the only one case, and in order to make the test pass, we ignore any dynamic type and we just cancel the feature?
Hmm.
I mean, if you look at the Facebook app on a modern iPad, it will pass the test, but it's a box in the middle of the screen. Discuss.
Hmm. Okay, so the question was that does a snapshot testing framework like this discourage kind of exploratory testing, because you have these fixed snapshots, and that's your goal is only to like get your unit as green. And I'd say that so like for instance with dynamic type, we also saw this as an issue when working at Doer. I can't remember, Fredrik, you might help me, if we actually, because we looked at how we could generate different screenshots for different sizes of dynamic type. I don't think we managed to find a good way for doing it right away, but it was certainly our ambition. And I think certainly if you can find a good way to automate that, it becomes much easier to actually test for all of your different accessibility traits and sizes, because if you have a huge map with all these screenshots, you can just glance through them and see, does this all look all right, especially if you're in a larger team and some people are working on individual UI components. You want to make sure that these will work in the bigger app and in various places. I think you get even more possibilities, and really it's up to your team to set the limits of how much you want to snapshot. You can take one view and just take a snapshot with its intrinsic content size, but do you want to try to stretch it in different ways? Do you want to test the right to left? I don't see any limitations of doing that.
Okay, so let's say the design changes and you got your snapshots stored in your remote repository, and so you change the way the view looks, and you push it to the repo, and the test wouldn't pass. So I mean the test on your CI, and would you have to somehow clean them up, or So regenerate them all again to make them work.
So the question was that what happens if you actually have design changes and then suddenly your tests don't pass, right? So, and what you do is you replace those. So you can do this in different ways. Either there's this extra argument, I can't remember the name of it, but it's like regenerate or something. It's not regenerate, but something else. Or what I usually do is just delete those files. So I know that, okay, this red was a bit too much. I want to change the shade of it. What I do is to delete it, change the color. It's going to regenerate a new file. And what's really interesting and really nice about this is that next time, then when you open this pull request for your coworkers to look at, they're going to have that image diff in GitHub, right? So they're going to see this was how the view looked like before. This is the new snapshot. And then you can immediately see visually what has changed. So I think that's really powerful as well.
I just wanted to add a learning to this. You said that quite often you include the snapshots in the pull request, and we've done that in where I worked previously. And we moved also the design review process in the pull request instead of a month later after the whole feature is done. And when you need to fix up things immediately after you've done them, it's much faster instead of after you forgot something. That's like a good added benefit if you can kind of include the designers in the iterative process immediately.
That's a great point. So a great added benefit is that designers can actually look at their pull requests and do design review as the code is being merged instead of having to wait for later. All right, so I think you had one last question.
You said that the location by default is where the test is defined. Do you happen to know if it's customizable?
So the question was that can you customize the location of the snapshot outputs? And I can't remember. I don't know actually. So I have to check that out.
Built into the project, but you can recompile the project yourself. I mean the SDK.
Okay, one last final question.
I wonder if it affects test coverage. If so, like how much?
Oh, that's interesting. So the question was, how does this affect test coverage reports? And I have no idea. I haven't looked at it. I guess it should affect test coverage report because, for instance, what you're doing here is just instantiating the view, setting the properties, right? So you can, if I'd had another property for this view which was never snapshotted, then that would show up in the coverage report that it wasn't snapshotted. So you should probably be able to use the coverage report to identify what properties you haven't really iterated through and changed when you snapshots. That's a great point. Okay, so I guess that's it for me. So thank you very much. Also, since I'm the last speaker for tonight, I want to give a huge hands up to Truecaller for hosting us here. Thank you, Truecaller. So I'm hoping we can stay here for a little bit while and talk amongst each other. That's awesome.
And I'd like to point out we have a bit of Slack you can grab on your way out. Feel like it?
So hope to talk to you soon, and if not, see you at the next CocoaHeads. Thanks.